number 1, today we're going to be talking about rational expressions applications. Our objective for today is that students will be able to understand and apply rational expressions to real-world situations and applications. Let's get started. One real-world application of rational expressions is if we're looking to find the area of a rectangle where the length and width are rational expressions. So, like example number 1, we want to find an expression to represent the area of the rectangle. So, if you recall, area of a rectangle is A equals length times width. So, if we're given that our length and width are these two rational expressions, in order to find the area, we're multiplying them together. So, we're saying 2x over x squared minus 12x plus 27 times x squared minus 81 over 4x to the third plus 36x squared. Alright, now we're just multiplying rational expressions together. So first thing we want to do is factor out what we can factor out. So this denominator we need to factor using our diamond method. So two numbers that multiply to 27 add up to negative 12. That's going to be negative 9, negative 3. So when we're factoring this first rational expression, still have 2x on top. On the bottom, we've got x minus 9, x minus 3. Then it's all of this times, up here we've got difference of squares, so we've got x minus 9, x plus 9. Then on the bottom, factor out a 4x squared. 4x squared times x plus 9. Then we want to cancel out what we can cancel out, simplify, right? If we've got common binomial factors like x plus 9, they can cancel out. We've got another x minus 9, those will cancel out. We've got 2x and 4x squared, so we can simplify this. The 2x will cancel out, and over here we'll be left with just 2x. Then we want to rewrite what's left. So what's left over here is nothing on top, so we just got a 1 on top. And on the bottom we've got x minus 3 and 2x. So our expression that represents the area of this rectangle would be 1 over 2x times x minus 3. And that would be our final answer. Alright, number 3, we're given that the area of a rectangular garden is this right here. This is our A. Now, the length is this right here. This is our L. We want to find an expression to represent the width. So we're looking for the width. Alright, so now we know the formula for area of a rectangle is A equals length times width. And we want to isolate that W because we're looking for the width. So in order to get W by itself, divide both sides by L. So the area divided by, my pen's not working great today, divided by L, alright, area divided by length equals the width. So what we want to do, if we want to find the width, we want to plug in our area and divide it by our length. So the width, if we know our area, is this right here. So area equals A squared over B minus B over our length, which is A over B plus 1. Now we've got a complex fraction right here, and we can simplify this to find an expression, a rational expression, that represents W, or the width. Alright, so, and when we've got complex fractions, first thing we want to do is have a single fraction on top in our numerator and a single fraction in our denominator. So this right here is b over 1. So in order to make them have a common denominator of b, multiply the top and the bottom by b. Same thing here. This is 1 over 1. So we need to multiply top and bottom of this fraction by b over b. Now, let me move this up so we've got more space. Alright, so now we want to simplify this. So over here we've got a squared minus b squared over b divided by a plus b over b. Now, we've got single fraction in the top, single fraction in the bottom, so we want to rewrite this as a division problem. So we've got a squared minus b squared over b divided by a plus b over b. Copy, change, change. All right. Complex fractions can't divide, so copy the first one, change it to multiplication, flip the second one. Change to multiplication, flip the second fraction. All right. Now, right here we've got difference of squares, okay? So, rewrite this as w equals a plus b, a minus b, all over b, times b over a plus b. Now here we've got common factors, common binomial factors. They're going to cancel each other out. B and b cancel each other out. So we're left with w equals a minus b. And that's our expression that represents the width of this garden. All right, moving on to number 5. I just quickly wanted to mention, if you look at number 4, you're going to see that it's talking about the area of a triangle. It's the same concept, but just remember that the formula for area of a triangle is 1/2 times base times height. And then you're going to do the same thing you did with numbers 1 and 3. All right, but number 5 is a little different. Now we're dealing with volume. And when we're talking about volume of a rectangular prism, we need to remember that the formula for volume is area equals length times width times height. So we multiply all three together. So if we're talking about the volume of this rectangular prism, we're going to take this times this times this. All right, length times width times height, and multiply it all together. So volume equals 5x squared minus 32x plus 12 over, and if my pen would work, that would be great, 10x to the third times 18x squared over 45x squared minus 18x times x squared plus 14x plus 48 over 36 minus x squared. All right, now we've got very complex multiplication problem, multiplying rational expressions here. So take it step by step. First thing we want to do is factor everything out. All right, so first things first, if we want to factor this out, we've got to do diamond, multiply A and C, and then group factor. Okay, so 12 times 5 gives us 60. B is negative 32. Two numbers that multiply to 60 add up to negative 32 would be negative 30 and negative 2. So then we copy the first one, 5x squared minus 30x minus 2x, and then our last term goes here, 12. Cut it in half. GCF of the first half is 5x. GCF of the second half would be negative 2. And so then our two factors here are going to be, let's see if we move everything up. All right, so if we're rewriting this right here, we get that volume equals 5x minus 2 times x minus 6 over 10x to the third times, looking at this one now, 18x squared can stay the same. 45x squared minus 18x, we can take out a GCF of 9x, and we're left with 5x minus 2. Now looking at this last one over here, if we want to factor the top using a diamond, two numbers that multiply to 48 add up to 14, 6 and 8. So we get times x plus 6, x plus 8, and the bottom right here, we've got difference of squares, right? This is 6 squared. So we can say 6 minus x, 6 plus x. Now we've factored everything, all right? Now we want to simplify what's left here in blue. So we want to cancel out any common binomial factors. So first things first, we've got 5x minus 2, 5x minus 2. Those can cancel out. X minus 6 and 6 minus x. This is our a minus b over b minus a. So they cancel out and we're left with a negative 1. Now here we've got x plus 6, 6 plus x. Those cancel out. That's a plus b over b plus a. And we just get a positive 1 there. Then we want to simplify our 18x squared and 9x. Divide by 9x, we get 1. Divide by 9x, and you get 2x here. Now we can actually simplify this again. We've got our 2x and 10x to the third. So divide by 2x, 2x will cancel out. Divide by 2x, and you're left with 5x squared down here. Now what's left? We've got negative 1. We've got nothing here. All right, nothing there. We've got positive 1, and we've got x plus 8. On the bottom, we've got 5x squared, and that's it. So rewrite our volume as negative 1 times x plus 8, all right, and times 1, but we don't have to write that, over 5x squared. Distribute the negative 1 to both of these terms, and you're left with negative x minus 8 over 5x squared. And that's your final answer. All right, number 7, we're dealing with perimeter. So just a reminder, perimeter is when we add all the sides together. So we've got L plus W plus W, right? Length plus width plus width. And we can simplify this to be equal 2 times L plus 2 times W. You can simplify that even further by taking out the GCF of 2, so 2 times length plus width. All right, now this is the formula we want to use because it'll make life a lot easier when we're multiplying out and simplifying our rational expression. So, if we've got P equals 2 times length plus width, we've got our length and width here, plug them in. So P equals 2 times x squared plus 8x, x plus 5, plus 15x plus 5. Now we've got common denominators here. We've got x plus 5, x plus 5. So combine the numerator. So we're left with P equals 2 times x squared plus 8x plus 15 over x plus 5. Then we can factor out our trinomial. Use our diamond, 2 numbers that add up to 15, multiply to 8, 5, and 3. All right, so scoot everything up so we've got some more space. And then we want to say that the perimeter equals 2 times, and this is 2 over 1, times, let's see. Actually, let's rewrite this as 2 over 1 times x plus 5, x plus 3 over x plus 5. Now, x plus 5 will cancel out, and what we're left with is P equals, or perimeter equals, 2 times x plus 3. All right, and if we multiply that out, we get that our perimeter equals 2x plus 6. And that's our final answer. Much simpler than what we started with. All right, last but not least, number 9, we're looking for the area of this trapezoid. So just a reminder, the formula for area of a trapezoid is A equals 1/2 times the height times the sum of the 2 bases. Okay, so that is our formula for area of a trapezoid. We've got our height right here. This is our h. Base 1 and base 2. Doesn't matter which one we call them, all right? Call this one base 1, this one base 2. If you call them opposite, does not matter. Okay? Then we're just going to plug them into our formula. So area equals 1/2 times our height, which is 12x over x squared minus 2x minus 35, times the sum of our bases. So we've got x plus 3 over x plus 9 over 2x. All right, now looking at the sum of our bases, we can't add them together until they have common denominators. So we need to multiply the top and the bottom here by 2 so that they have a common base or common denominator of 2x. Okay, so then we can rewrite this one as 2x plus 6 plus x plus 9 over 2x. Then this one right here, we leave the 12x on top, and then we want to factor out this trinomial. So two numbers that multiply to negative 35 add up to 2 would be x minus 7, x plus 5. And then it's still times 1/2 over here. Okay? Then, looking right here, we want to combine like terms. Okay? So, we get, starting from the left, moving to the right, area equals 1/2 times 12x over x minus 7, x plus 5, times, we've got 3x plus 15 over here, over 2x. Then we can simplify this right here, rewrite it as 3 times, right, take out the GCF of 3, x plus 5 over 2x times 12x, copy everything down, times 1/2. Now we want to cancel out our common factors. So x plus 5, x plus 5. What else can we cancel out? Divide by 2x, that cancels out. Divide by 2x, and you're left with 6 here. Then we can simplify this further. Divide by 2, you get 1. Divide by 2, you get 3. Then I think that's all we can simplify. So we move everything up so we've got more space. I know you can't do that on your papers. I'm sorry. Area equals what's left up here. We've got 1, 3, 3. On the bottom, we've got x minus 7. So 1 times 3 gives you 9 on top, x minus 7 on the bottom. And this would be our rational expression for the area of this trapezoid. All right, so I hope you learned a thing or two about the applications of rational expressions and how we use them to find area and perimeter of figures. Please look to the board to see what to do next, and I hope that you have a great day.